So it's the same way like the question you asked a few minutes ago, why can a molecule with a structure of NPR cannot exist? You can make NPR3 and you cannot make NPR4. And the one that you asked me is you can make NCl5, the same thing you cannot make, but you can make NCl3. And the answer is you cannot make this one. And the reason is we can combine the two answers that you have given us. So one of them is that because the molecule is too small to fit all the chlorine, and it require an expanded octet, but it cannot do the expanded octet. So I'll say that the nitrogen is small atom, smaller than the phosphorus, for example, it cannot make, and it requires expanded octet, and it cannot do the expanded octet, but cannot do it and do as only two energy levels. While we mentioned that you have to be at least in period number 3 to have 3 energy levels so that you can make the expanded octet with these elements. Okay, that was a good coincidence. Okay, second question. So second question, which of the following compounds would have the highest lattice energy? Okay, let's see. How can you determine the lattice energy? Is there anything here which has a higher charge? What do you think? C2H6, of course, I will not consider, so.
Yeah.
Because this is not ionic anyway. LIF has just +1 and -1. MgCl2 has +2 and
-1.
-1. Calcium bromide has +2 and -1. So now the one most probably will be magnesium chloride or calcium bromide. Which one I will use? The magnesium chloride or calcium bromide. Let's have a look at magnesium and calcium, because once we are having the same charges لازم ادور على مين؟ على size of the ionic radius. Ionic radius, huh? The ionic radius, what is the relationship between ionic radius and the forces of attraction?
The bigger the ionic radius, the less the attraction.
Okay, so charge and here radius squared. So it's inversely proportional to the radius. Okay. طيب, ionic radius of magnesium ولا calcium is bigger. Let's have a look at the periodic table again. This is the magnesium. Let's put it here. I have the magnesium and I have the calcium. Which one has bigger radius?
Calcium.
Calcium has bigger radius, so it is weaker or stronger? Weaker. And we need the highest lattice energy, so we'll use the magnesium. We also have the chlorine and bromide, the same thing. So chlorine also is smaller and it is stronger. So from both, you know, if I looked at this one, I'll find that this is smaller ion and this one is smaller ion. So this is inversely proportional to the forces of attraction. So lattice energy will be higher because the attraction is stronger. Okay. He is drawing here Lewis diagrams for the nitrate. Oh, this is a full question. And nitrite, this is question number 3. So we are having nitrate and nitrite ions. Choose the statement that correctly describes the relationship between the two ions in terms of bond length and bond energy. So the first one is the nitrate, that's NO3 minus. And the second one is nitrite, which is NO2 minus. This is the nitrite. Nitrite has longer and stronger bonds than nitrate, or nitrite has longer and weaker bonds. Nitrite has shorter and stronger. Nitrite has shorter and weaker bonds. Let's have a look. This is a very nice question. Trying to compare them according to the number of bonds. أنا شايف النيتريت عنده 3 different Lewis diagrams عامل ما بينهم resonance. والنيتريت عنده 2 Lewis diagrams عامل ما بينهم resonance. So how is this going to affect the length of the bonds and the strength of the bonds?
The more resonance you have, the stronger is the bond.
The more resonance I have, the stronger will be the bonds. يعني مثلا لو عندي فاكره السنه اللي فاتت كان بيجي لنا سؤال اللي هو بتاع البنزين رينج وبيقول لي الارقام بتاعته وبيقول لي البنزين رينج has resonance. Actually, resonating the bond makes it more unstable because it's like imagining that you don't have the bonds fixed in the same place. It's like it's moving. يعني what if I told you I have a relationship with this person and it is okay, ولا I am speaking to him one day I'm not speaking to him. Of course it will not be a strong relationship. Why? انا بكلمه يوم هنا البوند موجوده يوم ويوم مش موجوده, so it cannot be considered as a strong bond. While if I am having less resonance, يعني زي ما يكون انا مش مقلق, انا مش شاكك في نفسي, I'm sure. So just two resonance structures means it's going to be more fixed and stronger bonds. معنى ذلك ان ال stronger bonds هتكون النيترايت. And we know that stronger bonds should be shorter. So that should be shorter so that they will be strong. Actually, in the explanation also he is giving the bond order. So he is saying that the NO bonds in the nitrate have. So let's see this answer and try to understand it. So let's see the bond order as he calculated. So he said that the NO bonds in nitrate have a bond order of, I didn't copy the whole of it. Let me try to make another file. Oops. Close another window. Share screen again. And the new again. And this is again share. Oh, I have closed the application. That's why. That's why it has stopped sharing. Okay. Let me share the file again. Okay, sorry. So I'll try to screenshot the answer again. He said the NO bonds have this bond order. In the nitrate, and the first one. So how did he calculate it? He said it's 2 plus 1 plus 1 over 3. And he said this is equal to an average of 1.33, while NO bonds in nitrite have a bond order of 2 plus 1. So he is asking about NO bonds. This is NO bonds. This is 2 bonds. So this is 2 bonds, right? And then next time it is 1 bond, and then last time it is 1 bond. And how many times this was repeated? 3 times. So he said the first time is 2 bonds, 1 bond, 1 bond, that's 4, and he divided this by 3 times. So he get an average of 1.33. The second time the NO is 2, and then next time it is
1.
Okay, and it is 1. So again, Mr. Let me see, why did you choose these ones above this one? So he said, why are choosing this one specifically? So not have a bond order of 2 plus 1 plus 1. So NO, why we are choosing this one specifically? I'm not convinced with this, even I'm not convinced. So 2 plus 1, we have never done the bond order this way. 2 plus 1 plus 1 over 3. And he said is equal to 1.33, and then said the other one is 2 bonds and 1 bond. So 2 bond, I'm not sure what does he mean. Okay, the second one is 2 plus 1 over 2, higher bond order, and he found that it is equal to 1.5. Okay, I need to follow up for this one. To get how he is calculating the bond order specifically. Because after I draw this one, I have realized that there is also here 1 and 1. So why he picked 2? Why he picked this 2? Why he picked this 2? Why he did not pick this 1? 1 and 1. So N double bond 4 and N double bond 4 and double bond 4. Okay, I'll need to make some research about this one and see. But for the time being, this is a good explanation that if there is less amount of bonds which are going through the with shapes which are going through the resonance, so this means that it is more stable structure, and so the bonds will be stronger, and for the time being we'll take this explanation. Right, the next one, I'm just let us follow up for these things. This one is follow up. Okay. The next question is number 4. Okay, the graph below shows the amount of potential energy between two hydrogen atoms as the distance between them changes, at which point the graph would a molecule of H2 be the most stable. خدنا الجراف ده كذا مرة السنة اللي فاتت والسنة دي. كنا بنقول what happens when they are closest to each other. When they are very close to each other, the potential energy is very high. And when they are very far from each other, the potential energy is very high. Only when they are having the perfect distance اللي هي البوند length اللي هي عند point كام؟
point C.
عند point C هي ديت اللي أنا هقول عندها minimal potential energy. So this is the most stable one because this is the minimal potential energy, so it is C. Okay, and then number 5. 5 to 8 are all together. Unit 1 was okay for the other book. For most of the questions it was okay. Or
Yeah.
ولا كان في مشاكل شوية PES وكده؟
No, for unit 1 it is fine.
Okay, that's good. He said this is for questions from 5 to 8. This is 8. Okay. هو مديني السلفيت وقايل لي في عندي 2 Lewis diagrams. I have 2 Lewis diagrams for this sulfate. And then he told me that what is the molecular geometry in structure A. So structure A, what is the molecular geometry?
Tetrahedral.
Okay, I have 4 electron cloud things around the S. So it's most probably tetrahedral. What is the SO bond? So what is the S? Oh, this is tetrahedral because I have 4 things and no lone pairs. So 4 bond pair and no lone pair. That's why it's tetrahedral. And then what is the SO bond order in the structure B? Again, we are getting the question about the SO bond order. So it's very important to understand because we didn't face this one in the questions to the syllabus at all. In this example, what is the SO? I will tell you the answer also. What did he do? 6 total bonds divided by 4 locations. So 6 total bonds in structure B, 1, 2, 3, 4, 5, 6. So 6 bonds, and divided this by how many locations? By, he said 4 locations, and then divided by 4 locations, and then he gets the answer as 1.5. Maybe we can use this one to answer the previous one. So to find bond order, he just divided the 6 total bonds, which is 1, 2, 3. Let's try to do this the other one the same way. Okay. But here he is telling the bond order of every, and so 1, 2, 3, 4. Oh, now I got it. Okay. So in all of these 3, in all of these 3, he's having 4 bonds, right?
Yeah.
1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And how many locations as per him? 1, 2, 3. And here 1, 2, 3. And here 1, 2, 3. In all of them, the bond order is 4 over 3, which is 1.33, and here the same 1.33, and here 1.33. But in this one, how many bonds I have? 1, 2, 3, but it's divided on how many locations?
2.
2 locations. So 3 over 2, that's equal to 1.5. This is how he is calculating the bond order. And he said that the one which has higher bond order means it is shorter and stronger. Okay. طيب بعدين which of the following statements, so this one answer is C, which of the following statements regarding the structure B is true? The double bond must be located opposite each other due to additional electron repulsion. There are fewer sigma bonds compared to structure A. The bonds in the molecule are weaker than those in structure A. All bonds in the molecule are identical to each other. That's your best guess.
D.
Yeah, he gives the answer as D. So I can write, and he's saying that explanation that each bond can be written as either single or double, an equal number of times. So I can write this as single or double equal number of times. They all have the same bond order and are distinguishable. So let's see. Bond order again is 1. So they all have the same bond order. The double bonds must be located opposite each other due to additional electron repulsion. And there are fewer sigma bonds compared to structure A. Let's compare the sigma bonds here. I have 1, 2, 3, 4, and here still 1, 2, 3, 4. The bonds in the molecule are weaker than those in structure A. Okay, so as explanation, each bond can be written as either single or double, an equal number of times. Okay. Not very clear also this one. I need to draw up this one as well. Not very convinced with this one.
Okay. Why is it not quite A?
That's why I have a doubt, because there is actually repulsion will be increased if I make them close to each other. That's why it's best to have this shape. That's why I need to follow up with this question more. Okay. The explanation that he said all bonds and molecules are identical to each other said that the bond can be written as either single or double, an equal number of times, which I don't get what is the idea that it can be written as single or double. They all have the same bond order and are indistinguishable. Let me also follow up with this question. طيب, it's good to have new ideas ما خدناش قبل كده, because it will be very nice in the exams طبعا, خاصة ال AP. Which structure is more likely to correspond with the actual Lewis structure, the Lewis diagram for the sulfate ion? احنا عارفين ان احنا بنشوف الفورمال تشارج, صح؟ بنشوف الفورمال تشارج بتاع الاثنين علشان نعرف مين اقل واحد ليه فورمال تشارج, و accordingly we can find the most stable structure. دي الطريقه اللي احنا بنشوف فيها احسن structure دايما في الايه؟ في الريزونانس, مظبوط؟ طيب هو قال لي هنا single bonds are more stable than double bonds. It has the most unshared pair of electrons. There are more possible resonance structures. Fewer atoms have formal charges. Okay, so let's see the answers, how he put the numbers. طيب اداني structure A وقايل لي, let's see how he is doing this file. So S has 1 2 3 4, structure B 1 2 3 4. بعدين ده كل واحدة S عندها 6, so this is 6 and has 4 bonds. It has 6 valency electrons for this one, and it is making 4 bonds. So أول هي number of electrons على 2, so 1 2 3 4 5 6 7 8 على 2, so 6 minus 4 is plus 2. وبعدين الأكسجين الثانية عندها 6 ودي عندها 6 ودي 6 ودي 6, وكل واحدة عندها كام بوند؟ 1 2 3 4 5 6 7 8. عاملة كام يا مستر؟ عاملة هنا الاس عندها 1 2 3 4 مش كده؟ لكن دي عندها 1 2 3 4 5 6 7. He is calculating the separate electrons for it. وعندها ادي 1 2 3 4 5 6 7. قايل دي 7, وهنا قايل ان ديت 1 2 3 4. اوكي, and قايل this is minus 1, and he repeated the same. ولما جه هنا بقى لقى السلفر the same thing, it has 6 valency electrons, لكن حواليها 1 2 3 4 5 6, والاكسجينز ديت عندها 6 برضو. ديت الاكسجين دي عندها 1 2 3 4 5 6, ودي زيها 1 2 3 4 5 6, والاثنين دول عندهم 7 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. طلع الفورمال تشارجز بتاع دي 0 0 0 وجمع ده كله على بعضه. التوتال formal charge on each potential structure is -2 which is correct. on each potential structure يعني لما عمل plus 2 -1 يعني plus 1 plus 1 0 -2 دي طلعت -2 وهنا 0 0 0 -2 يعني الاثنين -2. فقايل الاثنين which is correct as that this is the charge on the surface. However, the right hand structure has fewer atoms with formal charges, so making it more likely the structure. This has 2 formal charges. So ابتدى يحسب الفورمال تشارج بتاعت ديت يلاقيها على كل اتوم والفورمال تشارج. I like the way he makes this table very nice. formal charge وبعدين جمع التوتال formal charge للاتومز كلها طلعت -2 وطلع هنا التوتال -2 وبعدين قال ان الاتومز ديت عنده 2 atoms only has formal charge وهنا عندي 5 atoms عندها has formal charge. That's why he picked up this one. So this is the answer. Fewer atoms have formal charge. Okay, that was a very good question. Actually, I'll put a star on here. This is a very good question.
Mr. I have a question. صح, we used to calculate formal charge by doing number of valence electrons of, like, let's say I was calculating the formal charge of sulfur. I'd do 6 minus and then number of unpaired electrons, which would be 0, minus, and I'm doing for structure B, and then I'd put half the number of paired electrons.
So let's do it. S, which is the number of valency electrons, minus.
You're doing for structure A or B?
B, as you said. B. So B minus
0 unpaired electrons.
Unpaired electrons 0 minus
half the number of paired electrons.
اللي هي 1 2 اللي هي 1 2 3 4 5 6. So
yeah, you get 0.
1 2 3 4 5. You said half of it, right?
No, yeah, but no, each bond contains 2 electrons.
You mean the bond, the bonded, the number of bonds. احنا كنا بنقول عليها the number of bonds أو half the number of the bonds. So it is 1 2 3 4 5 6. 1 2 3 4 5 6 7 8 9 10 11 12. So over 2 is 6, صح? So we get 0 the same way. Here he is just subtracting the number of, ده أنا اللي لاحظت إن هو بيعمله. He is just subtracting, which is actually easier. So that's why we need to experiment it in the other of atoms. So he is just subtracting the valency electrons from the electrons assigned only. بيبص على كل واحدة وحواليها كام إلكترون shared مع اللي حواليها بس من عندها. So 1 2 3 4 5 6. طب let's see oxygen also, the last oxygen. The last 2 oxygens اللي احنا كنا قايلين عليهم اللي هم الاثنين دول اللي هي this one, the red, let's make it red, this one and this one اللي هم كانوا الاثنين دول، صح؟ اللي عملهم بطريقتهم. اوكي. So we'll make it the same way اللي احنا هنسميها الاكسجين 2 ودي oxygen 1. So let's do it the same way. This is 6 valency electrons minus
0.
هم عندهم non-shared electrons 0 برضو minus
4.
هتطلع عندي هنا minus 2. That's different. So 1 2. Okay, actually because this is the first time, so that I can see that he is calculating with this one. بس عشان دي الكتب ديت formal books, that's why I'm putting too much belief in it. بس عايزين we need to calculate our way and see what will be the answers. Can we do it? So we did already for this one 6 minus 1 2 3 4 5 6. This is only 2. Okay, just for the sake of time, I'll just have to check the answers. Okay, I need to check the answers our way عشان احنا we just have very short time. I'll just try to make this one. فخلينا نعمل numbering. احنا خلاص عرفنا ده that's okay. You just need to keep it in mind for using the method of finding the bond order. So we can just put it here. You can just put the bond, how to find the bond order method. احنا قلنا ازاي الان finding. خلينا نحط الاكزامبل جنبه عشان يبقى البوند order. نحطه كده. ودي الطريقة اللي احنا قلناها 6 bonds 6 total bonds 1 2 3 4 5 6 على ال 4 locations. وبعدين عايزين نعمل الطريقة اللي هو بيقول عليها بتاعت calculating ال formal charges اللي هو قال عليها ال valency electrons minus ال assigned. Actually I like this too much, assigned electrons. That's why I need to do our way and then compare the answers. Hopefully we get the same answer. Okay. طيب عندي كمان next one is which of the following pairs of elements. You are always answering the AP questions برضه يا لينس. This has the portal itself. لازم يكون ديت ليها higher priority برضه. Okay. Which of the following pairs is most likely to create an interstitial alloy? Okay. احنا عشان اعمل interstitial, what is my condition? One atom has to be the atomic radius of one of the atom has to be much smaller than the other one. صح؟ يعني الانترستيشال هي اللي replacing ولا in between?
In between.
In between. So in order to be in between, you have to have one which has a big atomic radius and other one which is small. يعني باختصار don't pick two which are close to each other. ما تروحش تجيب لي الكوبر مع الزنك وتقول لي this will be interstitial. The size بتاعهم is very close to each other. Don't get me copper and tin and tell me they are interstitial. لا ممكن تروح تجيب لي الكربون، ممكن تروح تجيب لي مثلا الكربون هنا والايرون هنا. This is a good example for interstitial صح؟ Because they are very far from each other. طيب accordingly what will be the options that he gave me? اداني titanium and copper. I find that they are pretty close to each other. I have aluminum and lead. Where is the lead? The sneaky. This is not a bad option. I have silver and tin. I have Ag and I have tin, which I find that they are still close to each other, very close to each other, I think. Magnesium and calcium, which are also very close to each other. Okay, so I made my choice and I will ask you also to make your choice and tell me which one do you think it is?
Aluminium and lead.
Yes, aluminum and lead, and this is the right answer. This is the one that have large difference in the sizes. So aluminum and lead cause big difference in the size of the atom, atomic size or atomic radius. Okay, and then which of the following would be the best conductor of electricity? That's the most common question that comes in our book. 1 molar Kf or 1 molar CCl4 BAS SR BR2. Which will be the best conductor of electricity? Right. I have to remove some of them which are non-ionic أساسا.
CCl4.
CCl4 and the rest are ionic. Okay, and then
you have to check the charges.
Okay.
So it's K plus and F minus.
Okay.
BA is 2 plus and S is 2 minus.
Okay.
And SR is 2 plus and minus 1.
Okay. So in this case, our best option will be
D.
D directly. You don't have to look for. So this is plus 2 and minus 2. And this is +2 and -1. Number 11. كنا عملنا explanation الحكاية دي زمان صح؟ I don't need to do it again. 11. لما قلنا مرة إن أنا this one BAS give me 2 ions just for the reference, and this one give me KF give me also 2 ions, and so this is the number of ions. As long as you are conducting electricity also with the number of ions, so the number of ions make difference actually, not the charge. So I have SRPR2 give me one S and 2 PRs. So it's more related to the number of ions that you are getting, not the charges only. So here I'm getting 3 ions for every formula of SRPR2 I'm having. So if I have 1 million SRPR2, I'll be having 3 million ions. But here only 2 million and here 2 million. So the number of ions is most important, more than the charges of them. Okay. Type number 11 is the bond length between the two non-metal atoms is achieved under which of the following? Where the energy of interaction between the atom is its minimum value, where the nuclei exhibits the strongest attraction, the point at which the attractive forces is larger than the repulsive forces, while the closest point in which a valence electron from one atom can transfer to another. Okay, what's your best option?
B.
B. Why it's B? Nuclei exhibit the strongest attraction to the electrons of the other atom. So the nuclei of each atom exhibits the strongest attraction to the electrons of the other atom. Actually, I think the answer is A. I wouldn't mind. Actually, I was saying it's either A or B. It's saying that the bond length always corresponds to the point at which the potential bond energy is at its minimum value. This is the one that we saw in the picture. The energy of attraction between atoms is at its minimum value. اللي احنا قلنا مش الانرجي of attraction. احنا في الرسمه بتاعتنا كانت بتقول البوتنشال energy. Attractive and repulsive forces are equal in stable bonds. So he has chosen A, saying that the energy of interaction between the atoms is at its minimum value. So this is represented by the picture that we have drawn here. This is the point at which the potential energy of the molecule or the potential energy of the structure is at its minimal value. That's why he picked this one over B. Actually, I didn't see that B is that much wrong where the nuclei of each atoms, but that's how he is stating that this is going to be the answer. Of course, that one I have excluded because there is no transfer, because he already said here that this is non-metals, and the point at which attractive forces is larger than the repulsive forces. Of course, this is also wrong, otherwise the nuclei will hit each other. Okay. طيب أنا عايز أحل 12 وال 15 مع بعض. Consider the Lewis structure for the following molecules. Which molecule would have the shortest bonds? I have CO2, CO3 minus, NO2 minus, and NO3 minus. And he said consider the Lewis structure and try to find the shortest bond. So just to summarize, he tried to find the structures of all of them. And has drawn it like that. So he made the CO2, which is having one structure only. And then he made the carbonate, which have 3 structures, and made the NO2 minus, which have the 2 structures, and the NO3 minus, which have 3 structures. And he asked which one has the shortest bond. Okay, actually السبب اللي احنا قلناه في اول مره can be helping here also. I can see that it can be helping. هو بس ممكن يكون confusing if we have two structures with a similar number of resonance. In this case, is not going to help. Do you remember what we said at the first explanation? We said that the structure which has least
Less
number,
resonance.
yes, will be shorter and hence stronger. And the answer here is A. Is the one which is the answer. So it has one structure only. And this is a very good explanation. It will only be difficult to use it if we have two structures with the same number of resonance. Like if I have three structures or two structures with three resonance, then I cannot explain it. I will have to go back to the bond order again. So let's see the bond order and try to calculate it the same way we said. احنا قلنا يا مستر البوند order again. This is the number of bonds divided by the locations. So what is the number of bonds in the first one? I have 1, 2, 3, 4. So number of bonds على locations. So I have 4 divided by
2.
2. So it's equal bond order 2. And then these ones I have 1, 2, 3, 4 divided by 3. 1, 2, 3, 4. That's 4 divided by 3. And here I have 3 divided by 2, which is 1.5. Can calculate for us what is that one. 1, 2, 3, 4 over 3. 1, 2, 3, 4 over 3. 1, 2, 3, 4 over 3. So this is all the same. So what's 4 over 3? 4 over 3 is equal to 1.33. So this means that the highest bond order is 2. And we said that the higher bond order equal to shorter and stronger bonds. Okay. Stronger bonds. Okay. Saying which molecules are best represented by multiple resonance structures. What's the meaning of best represented by multiple resonance structures? أنا عندي CO2 and CO3 2 minus. لا CO2 ما فيهوش. CO3 2 and NO3 minus. CO3 minus. CO3 2 minus. تمام هما الثلاثة فيهم resonance والكربونيت بس اللي ما فيهوش. Can you see the question or it's very tiny?
No, it's fine. I can see it.
Okay, so the only one here is the carbonate not showing. So he has picked this one. Yeah, all 3 of them has resonance. The only one that has no resonance. طبعا هو معتمد يعني احنا طبعا مسهلين الدنيا because we draw the Lewis diagrams. فطبعا الدنيا بالنسبة لنا سهلة جدا لكن انت خدتي بالك ان احنا in the question we don't have the Lewis diagrams يعني we have to draw them so that we can answer. So احنا معتمدين ان احنا عندنا already طلعناهم وبنحل منهم. But we have to draw them, which states the big importance of drawing the Lewis diagrams easily and fast in the exam. Then شايف عشان أعمل bond order I have to know all of that. So this has to be memorized very 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 well. Okay. طيب. Which molecule would have the smallest bond angle? السؤال ده المفروض تبع اللي فات. Has the smallest bond angle between terminal atoms. طيب بيقول لي which one have the smallest bond angle between the terminal atoms. اوكي انا عندي الاول واحده 180 وعندي number 3 I have it which is like this is like water صح. This is like water. This is NO2. Actually this is AX2E which is like water, which is almost 104 I think, right? NO2 صح مش كده؟ وعندي هنا ال 3 structures ديت 120 and this is 120. So this is the smallest one of them is the nitrite. كده this is 120, sorry 180. This is 3 structures, so this is 120 and this is 120. There is no lone pairs in the middle مش كده؟ bond pairs بس. And this one all has like almost 104.5. That's AX2E. طيب, so it is NO2 minus. This has the smallest one. Okay. The free response, the ion below. On unit 1 and 2 are 3 كمان 1 and 2 are very tricky. معظم الناس بتهيأ لهم انها اوكي بس انت شايف الاسئله is also عايزه experience كويس جدا. The ion below known as enolate has a formula of C2H3O and 2 possible Lewis electron diagrams. Using the formal chart, determine which structure is the most likely correct structure. Okay. Let's do it our way, Yalayan, this time and compare it. I will show you the numbers that he has given. So what's the formal charges for the first C, for the second C, and for the oxygen? What is the formal charge for the first C, the second C, and the oxygen? So let's see structure 1. Now let's call this one A and call this one B. Okay. So for A, I will say C1 is
4 minus 0.
Okay, so it is
minus 4.
Okay, and C2 is
No, mister, I think C1 is supposed to be 0.
You said 4 minus 0, right?
Yeah, 4 minus 0 minus 4.
4 minus 0 minus 4, so it is 0. And C2?
4 minus 0. Yeah.
Okay. 4 minus 0 minus
4.
So it's still 0. And then oxygen?
6 minus 6.
Why 6?
Minus, because the number of like electrons that are unpaired.
Okay.
And then minus 1.
Minus 1. So it is negative 1. Okay, so the total is?
Negative 1.
Negative 1. Second one is? C1 is?
4 minus 0 minus 4.
0. And then C2
is 4 minus 2 minus 3.
4 parent C minus 2 non-paired minus 3. So it's equal to?
Negative 2. Negative 1.
4 minus 2 is 2, minus 3 is negative 1. And oxygen equal to?
6 minus 4 minus 2.
Minus 4 minus 2. So that's 6 minus 6. So 0, right? And then this is negative 1 again. Okay, this one has 1 atom with a formal charge, and this one has 1 atom with a formal charge. So which one is most likely the structure? And let's compare this against his answer is saying for this question number. First one in the free response. He has given the same value. We have got a similar one to this. او لو انا مش غلطان احنا اساسا حلينا السؤال ده قبل كده زمان جدا واحنا مره بنحل بس بيبر. Yes, I remember now. So according to what we'll decide. By the way, he found the two answers to be the same numbers. He said the same way the valency, and then said the assigned. So he got 0 and 0 and minus 1, and then he gets 0 and minus 1 and 0 like us. And then when he added, he found minus 1 and minus 1. But then how we are going to decide which one will be more stable at the end? لو أنا عندي أتوم أكسجين وعندي أتوم كربون، مين الإلكترونيجاتيفيتي بتاعتها أعلى؟
oxygen.
الأكسجين is more electronegative, so most probably لو عندي formal charge negative formal charge، النيجاتيف formal charge ده هيكون على الأكسجين ولا هيكون على الكربون؟
Oxygen.
Oxygen, and I can see the structure here is the one that contains the oxygen on the formal charge on the oxygen, but this one has the formal charge on the carbon. So in this case, most probably this is my structure A. Why is that? Because oxygen is more electronegative, and so it's most probably is the one that have the formal charge on it. What is the hybridization؟ أنا فاكر إن إحنا حليناه مرة زمان جدا وإحنا بنحل past paper في أول السنة. أوكي. What is the hybridization around the atom X?
For structure A, it's sp.
Why sp?
No, sorry, sp2.
sp2. Okay, and the other one is
sp.
اوكي. هو عايز بيسأل على الاثنين، مش كده؟ على دي ودي. There are three groups around the hybridization is sp2. وبيتكلم عن انهي واحدة؟ X in structure. in the structure you choose. خد بالك. In the structure you choose in A. طيب يعني الواحد لو جاب دي غلط هيجيب دي غلط automatically. Okay, how many sigma and pi bonds has the atom formed؟ الX CX ديت كم سيجما؟
3 sigma bonds and 1 pi bond.
It has 3 sigma bonds and 1 pi bond. And hydrogen ion attaches itself to the enolate ion عشان يعمل حاجة اسمها C2H3OH أو C2H4O. Draw the Lewis diagram of the new molecule. So C is attached to H and C and X and H and oxygen. Okay. Okay, الهيدروجين دوت هيدروجين اتوم ولا هيدروجين ايون؟
Atom.
No, he said hydrogen ion. صح؟ So
يعني
it has no electrons. It has no electrons on it. صح؟ No, I hope this is not a mirror. Okay. So it means that it has no electrons. صح؟
yeah.
So it means the only way that it attaches is through the electrons of the hydrogen. Okay. Draw the Lewis diagram. That was only one question. One question only. Okay, Elaine. I think the questions are not. That was the end of the session.